everyone. So now I'm going to have another example of the standard deviation, sample variance, and range, also known as the measures of variability. I've already preloaded or written down some data. This all comes from Dr. Jacob Kaplan's website, crimedatatool.com. Makes your life a lot easier when you're looking for different types of data related to criminal justice. So what I did was find 5 cities in Arkansas, 5 cities in Texas, and looked up their city law enforcement agency, their police department. What I also wrote down next to them are their 2018 violent crime rates per 100,000 residents. So with that, I haven't done any of this before. I looked at some of the cities that I'm familiar with, some that I've lived here in Arkansas, and some I visited in Texas. So I wanted to see what is the variability across these cities in 2 different states. To help us along the way, the first step I recommend is going ahead and writing down the standard deviation equation. So we have S equals the square root of the sum sigma of the value minus the mean squared over n minus 1. So here, remember, the big step with the square part is to do it individually. Once you do the subtraction part, and n minus 1 gives us a more conservative estimate when doing so for our final standard deviation value. So to start off with, we can go ahead, we'll just start with Arkansas. So I'm going to draw a line down the middle just to separate the two to make it a bit easier on myself. So with the range, and I have a calculator on my desktop so you won't be able to see it, but with the range, remember it's the high value minus the low. So I'm going to go ahead and do that over here. So we have, for Little Rock's the high, 1449, minus the low would be 207. So our range equals 1,242. Obviously, that's quite a large range. If you're not familiar with Arkansas, Little Rock tends to be one of the most violent cities with a population over 100,000 in the U.S. I put on here Fayetteville, where I reside now, work at the University of Arkansas, then some of the neighboring towns of Rogers and Bentonville. And then Fort Smith is typically brought up in the conversation with Arkansas. If we're looking at cities that do have crime, you can still see it's not relatively as high as Little Rock. The next step would be, if you look at the standard deviation equation, is we need to know the mean value and be able to subtract it. So I'm going to switch my color over just to make it more identifiable to red. And with that, so remember, for the mean, we want to add all the values together, then divide by the sample size. So here for the mean, it's going to be 1,449, 571, plus 831, plus 438, plus 207. And if you look these up on the Crime Data website, I did round these off just to make it a bit easier on myself while doing this. There are tenths decimal places on it. So if you have questions, you can look at that and see what the actual one is. I just went ahead and rounded to make it a bit easier. So now I'm going to add up the numerator. And for the top, the numerator, we get 3,496. Here we divide by 5, and we get a mean of 699.2. So now that we have our mean value, we can start the process of figuring out the standard deviation for our 5 cities for Arkansas. So I'm going to copy over the crime rates for each city again, just move it over into another column so I can do the subtraction and show the steps of the process itself. So we have Little Rock's, Fayetteville, Fort Smith, Rogers, and Bentonville. So with that, the first step, if you remember in the formula, is to do the subtraction from the mean. So now I'm going to go ahead and do the subtraction. So this is our x, that's our value. We're going to subtract the mean, which is 699.2. I'm going to copy that down. So now we want to obtain the difference for each one of these. This will be our difference of those. So again, I'm going to go ahead and do that on my calculator in front of me. So for the Little Rock, 749.8. For Fayetteville, it's negative 128.2. For Fort Smith, it's 131.8. For Rogers, Arkansas, it's negative 261.2. And then for Bentonville, we get negative 492.2. So here we now have the difference part, so the numerator part of the equation. Before we sum all of these values up, we need to square each one. So I'm going to go ahead and put the square up here so we realize that. So these will all become positive now. And now I'm going to go ahead and do that for each one. Let's see. 749. All right, as we go down the list, don't forget to square each one of them. And then we have Rogers, 68,225.44. And then for Bentonville, our last one, we have 242,260.84. Now that we have all of the squared values for each city, this is when we sum them up. So this is where the sigma comes into play. If you're familiar with this in Excel, it is the sum feature. It also has the sigma value next to it. So here we have the sum. And when you add all of these up, we get 906,492.8. So here we now have the numerator of the equation. For our denominator, n minus 1, keep in mind our sample size is 5. We have 5 cities. So we're going to divide this by 4. And we get 226,623.2. Now if you look at this now and you remember the equation for the sample variance versus standard deviation, the only difference between the sample variance and the standard deviation is the square root at the end. So this would be your standard variance. It's in squared units, so it's not as meaningful for us here. That's why we take the square root to put it back into the original units. So now is when we would take the square root, and our standard deviation for Arkansas is 476.05 violent crimes per 100,000. So there we go. A bit larger numbers, and this is why it's always important to have a calculator. Even if you have an Excel in front of you, you can use it to double check. I did that to make sure I was doing it correctly along the way. So with that, we know that for the 5 Arkansas cities, the mean is about 699 violent crimes per 100,000 residents, with a standard deviation of about 476. So if we do +1 -1 around the standard deviation, we can get, let's scoot this over again, so plus -1 standard deviation from the mean. Remember that our mean is 699. I'm just going to go ahead and round. So we're going to add 476. We're going to subtract 476. And pull up my calculator. 699 plus 476 gives us 1,175. And if we do 699 minus 476, we get 223. Now since we did +1 -1 standard deviation around the mean, we would expect about 6 to 8% of our sample, in this case cities, to be within these two values here. If you see, and it just so happens it's not in bad order here, we have one city that's below 223. We still have one that's above. Keep in mind we only have 5 cities, so our sample size is incredibly small. But as the sample size increases, it typically reflects this pattern itself. All right, let's hop down to some of the Texas cities now. I'm going to switch colors. Again, the first step is to identify the first variability range, or measure of variability, which is range. So our range here, our high is 1,032. From here, I don't believe Huntsville was actually 33. Looks like I was missing a 1 on that, 331. So with that, we now have our high and low values. So it's Houston minus Huntsville. And our range for the Texas cities would then be 1,032 minus 331, 701. Remember, this is a broad descriptive statistic here. It's not telling us the variability within that range. We just know the min and max and the range in between those values. We don't know where the cities in that range fall. We just know they fall somewhere between 331 and 1,032. And now, similar to the Arkansas City example, if we come back up to the standard deviation equation, we need to calculate the mean of the Texas cities first, so we can start the process of subtracting from the actual values. So for the mean, and then numerator, we're going to have 1,032 plus 768 plus 382 plus 627 plus 331. And that's over the sample size, which is 5. So we get here, and I'll bring up my calculator, 1,032, 768, 382 plus 627 plus 331. We have 3,140 divided by 5, which gives us a mean value of 628. So now that we have our mean, we can come over here and now calculate the difference between our value minus the mean. So I'm going to bring these numbers over again, similar to above. So 1,032, 768, 382, 627, and 331. That's why I probably didn't have those dull spot again. 627, 331. So with these are our values, and I want to subtract the mean that we just calculated, the 628, to obtain the difference between the two. So that will give us our difference. So go ahead and calculate those. For the first one, what was that? Houston, we get 404. For Dallas, we get 140. For Austin, we get negative 246. For San Antonio, we get negative 1. And for Huntsville, we get 297 negative. If it lets me write it there. There we go. So here, remember, again, before you sum these values up, it's important to square them before summing. So again, square each value. This will get rid of the negative signs for us. So we have our squared values now. And here we get, at the top, we get 163,216, 19,600, 60,516, 1, then 88,209. After you've squared each value, similar to how we did in Arkansas, we're going to sum these values, so just add them all together, and that's when we get 331,542. Remember, similar to above, we have the same amount of cities again, so it's 5 minus 1, which gives us 4. So that's our denominator. And here we get 82,885.5. Similar to above, remember this would be our sample variance. And I still bring that up. I make it a point here because later in the semester, we'll use the sample variance as a calculation in other statistics. So I want you to be familiar with it now. Very similar to the standard deviation, just different for this part. Keep in mind, that's why we have the s squared. It's still in squared units. So to get it out of squared units, we want to take the square root of this, and that will result in a standard deviation value of 287 point, once we round, 9 violent crimes per 100K. So now if we want to take a look at both of them, so we have Arkansas cities and Texas cities. We have the standard deviation for both. We have the mean. The key takeaway is typically when you have a lower standard deviation value, it means their values across or closer to the mean itself. When you have a large standard deviation, there's more variability from the mean itself. So if we took the Texas cities and compared to the Arkansas cities, the Texas cities that I chose by convenience are closer to the average violent crime rate for Texas cities than in Arkansas itself. We see the 287, so 288 to about the 476. There's greater variation in the Arkansas cities than in the Texas cities. If we wanted to look at if there's a potential skew in the data, we did not calculate it, but we easily can. So we have I'll do it in green. So if we look at the Arkansas cities and we want the median, let's see, 207, 438, 571 would be our median. And for Texas, if we go 331, 382, 627. So we can put it along a curve of, let's see, so for Arkansas, the mean is greater than the median. So our median is 627 with the mean being to the right of it is 699. So we know the tail of the distribution is going out to the positive side, so we at least know there's a slight positive skew when the mean is greater than the median. And eventually we'll get to calculating the actual skew value. And then for 627, it's pretty close to the actual mean, as you can see here. So if we have a mean value of 628, it's only one violent crime per 100,000 residents different. That's 627. So fairly close together. Would likely not be significant, but a slight negative skew. So the tail will be going out to the left. But keep in mind, these are both small, very small sample sizes of 5. We could pull all cities for Arkansas and Texas and look at their police department statistics to get a better understanding of that and if there's the impact of skewness and even kurtosis on it. So here is just an example of calculating standard deviation by hand. You can take this same data set and put it into Excel and do a quick, if it'll let me do it. There we go, let me move it up. It'd be STDEV and then your numbers within it. And then you'll get a resulting 476 and 287. Much quicker to do in Excel, but it's important to understand what you're doing by hand, the math behind it. So if there's any questions, please reach out. Always happy to make another video.